Hello, precious one. I welcome you once again to Kenyako Mathematics Classroom. Today we are going to look at how to find the determinant of a 2 by 2 matrix, how to find the inverse of a 2 by 2 matrix, and how to find the determinant of a 3 by 3 matrix. So we are looking at how best we can find the determinant of a 2 by 2 matrix. Determinant of a 2 by 2 matrix. So now let's assume that we are given the matrix A to be A, B, C, D. A to be A, B, C, D. Now we have 2 rows, 2 columns. So this is a 2 by 2 matrix. Now, how do we find the determinant? The determinant is written as either DET of A, that is determinant of A, or is written in this form. And this is equal to, we multiply the first element by the fourth element. That is A times D. We have A times D minus the second element times the third element. That is B times C. And that is how we find the determinant of a 2 by 2 matrix. So when you are given a matrix, let's assume you have a matrix A to be equal to 1, 2, 3, 4. And you are asked to find the determinant. That's a symbol for determinant. So you have to find the determinant of this particular matrix. Don't forget that you are given the matrix. The matrix is A, 1, 2, 3, 4. And you are asked to find the determinant of A. Don't forget that this is the first element, the second element, third element, and the fourth element in the matrix. You know that the members in the matrix, we call them elements. So when you are finding the determinant, you multiply the first element by the fourth element. That is 1 times 4 minus the second element times the third element. That is 2 times 3. And this will be equal to 1 times 4 give us 4. 2 times 3 will give us 6. So 4 minus 6 will give us minus 2. So the determinant of the matrix A is equal to minus 2. The determinant of A will give us minus 2. So that is how we find the determinant of a 2 by 2 matrix. Don't forget, it is the first element multiplied by the fourth element minus the second element multiplied by the third element. Whatever you are getting is the determinant of that particular 2 by 2 matrix. That particular 2 by 2 matrix. Okay, so now we are going to look at how to find the inverse of a 2 by 2 matrix. Now that you know how to find the determinant, we are going to look at how to find the inverse of a 2 by 2 matrix. The inverse of a 2 by 2 matrix. Now, let's assume that we are given the matrix A to be A, B, C, D. The inverse of A, that is the inverse of A, is written as A exponent minus 1. That's how it's written. So when you see this, that's the inverse of A. If it is B, it will be B inverse. If it is C, it will be C inverse. But because the matrix given is A, then the inverse of A will be written in this form. So if you are asked to find the inverse of A, how do we find the inverse of A? We are given the matrix A to be equal to A, B, C, D. And we are asked to find the inverse of A. So A inverse is question mark. That's what we are calculating for. Now, the inverse of A is 1 over the determinant of A. Then the D takes the position of the A. Then the A takes the position of the D. Then you negate the second element and you negate the third element. When you simplify this, whatever you are getting is the inverse of A. Whatever you are getting is the inverse of A. So now we are going to, don't forget that before you find the inverse of a matrix, you need to find the determinant, because you can see that the inverse of A is the same as 1 over the determinant of A. Then the D now takes the position of the A, then the A takes the position of the D. So you can see that D is here, then A is here. Then you negate the second element, then you negate the third element, then you simplify. Whatever you are getting is the inverse. So let's take a look at this question. Let's use the same matrix. A equals 1, 2, 3, 4. Let's assume that we are asked to find The inverse of A. So the inverse of A is question mark. Now we know that in finding the inverse of A, it is 1 over the determinant of A. Then the D here, we have A here, then minus B minus C. That is the general rule for finding the inverse of a 2 by 2 matrix. So we first have to find the determinant. Now you know that the determinant of a matrix, a 2 by 2 matrix, is the first element multiplied by the fourth element minus the second element multiplied by the third element. So we have 1 times 4. That is 1 times 4 minus 2 times 3. Then we have 2 times 3. And don't forget this one, 1 times 4 is 4. Minus 2 times 3 will give us 6. So 4 minus 6 will give us minus 2. So the determinant of the matrix A will be equal to minus 2. Now, in finding the inverse of the matrix A, we know that it is 1 over the determinant. 1 over the determinant. So we have 1 over minus 2. Don't forget that the 4 takes the position of the 1, and the 1 takes the position of the 4. Then we negate the second element, then we also negate the third element. So we have 4 up here, then we have 1 here, then we negate the 2, then we negate the 3 and simplify. Now we are back to multiplication of a scalar by a matrix. And when a scalar or a constant is multiplying a matrix, the scalar multiplies all the elements of the matrix. So this is minus half multiplied by 4, and this is giving us minus 2. Then we have minus half also multiplied by 2, minus 2, and we are getting 1 here. Then we have minus half multiplied by minus 3, and we are getting 3 over 2 here. Then we have minus half being multiplied by 1, and we are getting minus half. So in general, this would be the inverse of the matrix A. This will be the inverse of the matrix A. So the inverse of the matrix A is minus 2, 1, 3 over 2, then minus half. That is the inverse of the matrix A. That will be the inverse of the matrix A.